Hi everyone and welcome to our channel specialized in designing MATLAB applications. In this video, we are presenting one of the most popular root finding methods. Yes, it is a Newton-Raphson algorithm. This app is somehow simple compared with other more advanced Newton-Raphson apps that will be presented soon on this channel. However, this app is so powerful for solving one-dimensional problems. No matter if they are linear or nonlinear, real, imaginary, or complex numbers, I mean the roots, if they are in real number or imaginary or complex, the app can find the derivative and do all the iterations, starting from the initial guess defined by the end user. The app has a controllable early stopping criterion, which is used to terminate the iteration process once the absolute error is within the minimum acceptable error. Or in another word, tolerance. The app can beautifully show all the iteration steps with full information, such as iteration number, old and new values of the independent variable x, the values of the dependent variable f of x and its derivative df over dx, and finally the absolute error. All these results can be exported as .xls, .xlsx, .xlsp, .xlsm, and .csv sheets. The iteration process can be aborted at any moment, and the table can be easily cleared either automatically when the run button is pressed or manually through the clear button, either through this clear button or when we press on this button, run. Now let's start the app to see it in action. We can see that this is the f of x and this is the derivative. We can just start the algorithm. We can define starting point or initial guess, maximum number of iterations, and tolerance. Let's say that everything's are okay for us, and let's run the algorithm. We can see that the absolute error is decreasing till reaching the acceptable error. So we can see that it is less than this value, so it will stop. And we can see also here that f of x equals 0 when x equals 3.4. So we can see that it is converging to 3.4. And we can also export it to Excel sheets with different formats. We can see here, we can select any format of these. Now let's write another function to solve it. Let's say, for example, x to the power 3 times sine of x minus cosine of 0.3, or let's say pi times x over, for example, 5, and is also divided by x. Okay, so what is the derivative? Will be this equations for the derivative, and let's start also iterating this function. So we can clear it, or we can just press run and it will clear this table and give us a new solution. So this is the solution. It is within just the 3 iterations and will converge to this value. Let's write another equation that gives us the solution or root in complex number. So we can say that square root minus x times sine of x to the power 2 x squared minus log of x. Okay, and let's run it. We expect a complex number as a value. So we can see here it has the ability to find complex number. Now let's export it to, for example, .xls for all Excel sheets. Let's say results. Let's press save. So this is our results. We can see the results. exported from the program. We can see here the complex solutions or the complex numbers. We can see the results in complex format. We can also see the real part, just the real part, which is this result. We can see it here, just the real part, because here we can see the real part. For example, this one, 2.0053. So we can see it here also, 2.0053. And we can see it here with more decimal places. And also, we can see from here the imaginary part, for example, 2.7337i. And we can come here and we can see the imaginary part of the solutions. So we can see here more decimal places, minus 2.73373137, all these decimal places. And the overall results for complex format, we can see them here. So this is the solution of this equation. This equation. At the end, you can download the entire project from the link provided below in the description box. Thank you for watching, and don't forget to subscribe to see more apps. Goodbye.